So I'm Naveen Arunachalam. I'm a fourth-year PhD student in chemical engineering in Heather Kulik's group. I do machine learning for materials discovery. I do not do quantum computing or blockchain. So I hope you guys learn a bit from this, same way I learned a bit to get to this point where I can teach you guys about this. So the learning objectives, a bit ambitious. So first, after this 10-minute presentation, I want you to be able to explain the role of computation on the blockchain, to be able to describe the process of deploying a smart contract for quantum computing, and to be able to formulate new ideas for blockchain services. So let's dive right in. So the origin of this is that I wrote a paper for SIGTBD, which is kind of a joke conference at MIT. People do really high-effort jokes for this conference, and this paper was in the proceedings last week. So the title of this paper is Soulmate, a linear algebra package for cloud-based machine learning via blockchain with applications in IoT for Web 3.0 and quantum computing in the metaverse. So the goal here was to pack as many buzzwords as possible into the title, and to do this, I developed Soulmate, which is a linear algebra package for the blockchain. So you can think of it like MATLAB for Bitcoin. So all right, so some background here. So Bitcoin became popular in 2008 because, like, money. And then later, Ethereum became popular because it's, like, also money. But one thing that distinguishes Ethereum from Bitcoin is the ability to do small computations every time you do a transaction. So because of this, you can have things like automated market makers, which collects transactions from a bunch of different people and decides on optimal pricing using mathematical formulas. So here is an infographic from BlockGeeks. I do not know what BlockGeeks is. This is just the first thing that came up when I searched up how does Ethereum work. So basically, this is explaining what a smart contract is. But the main idea here is that there's two types of users in Ethereum. There's people and there's computers. So people are the ones who decide to go to Coinbase and buy some Ethereum. The computers are the ones that are aggregating transactions and deciding what to do with them. What these objects look like, they look like pieces of code that are just run on a public blockchain and decide on which transactions to accept or reject. So for learning objective 1, to explain the role of computation on the blockchain, I'm going to give you a short exercise. So first of all, based on the information I've provided to you so far, how would you define a smart contract? Just discuss this among yourselves. If there's anyone sitting next to you, if you're sitting alone, just think about it very carefully. And also, the second follow-up question is that smart contracts use math and code to decide on financial transactions. So what kinds of services could you imagine smart contracts could be used for? So I'll give you like a minute or so. All right. So I heard some stuff among the audience. We have some confusion. We also have some understanding. So we're all over the place right now, but the fact that you guys have been able to talk a bit about smart contracts puts you like way ahead of the game in terms of what people know about the blockchain. So what I'm going to do right now is tell you a bit about what smart contracts can be used for. So one of the biggest exchanges in Ethereum is called Uniswap. And basically it emulates a trading desk. So for example, let's say you want to exchange US dollars for Japanese yen. What a trading desk will do is have a bunch of people who are looking for yen give dollars to them, and have a bunch of people looking for dollars give yen to them. And then it decides how much is going to price the exchange between those two. So when you use Uniswap, you get this portal that looks like this. You can choose what currency you want to start with and which one you want to exchange it to. And you'll have thousands, millions of people using this interface and submitting transactions. And the Uniswap will use simple mathematical operations like plus, minus, add, divide in order to decide on pricing. Now, from here, the reason why this is the case is because smart contracts are written in a language called Solidity, which supports only basic mathematical operations. So this is where I come in. The question I had is, can we do more? Can we solve an eigenvalue on the blockchain? So what I did is that I wrote this paper and wrote a matrix library called Soulmate, which allows you to do more complicated operations like eigenvalue solving. And here is an example of the first smart contract ever written that solved an eigenvalue on the blockchain. So now that we can solve eigenvalues, we can solve linear algebra problems. like this series of equations here. But the question I asked myself was, can we do more? Can we do machine learning? So the next thing I did was a big brain move, which is do multiple linear regression and then call it machine learning. So here, this smart contract is a service that when deployed on the blockchain, someone can send in a financial transaction along with some annotated data, for example, a set of training data, and the smart contract will perform a linear regression and output the regression parameters for that data. So I asked myself, can we do more? Can we do quantum computing? So here is a 2-qubit quantum computer. There is 2 inputs. Each one is a vector of length 2. And the output is a Bell state, and that's a vector of length 4. And it turns out you can do a simulation of this quantum computer on the blockchain because all it is a 4x4 matrix multiplication. So what we're going to do is talk a little bit about how we can deploy such a contract on the blockchain. So the first thing that you'd want to do is download this linear algebra package that I wrote called Formulate. And after that, you want to write up some code using code editors such as VS Code to encode the elements of your unitary matrix for this quantum circuit. Then you want to spin up a test blockchain on your computer, run the contract on the test blockchain, and make sure that the results are what you expect them to be. Receive requests, check for errors, and then deploy it to the actual blockchain. So the figure on the right kind of shows a simplified schematic of what you end up with. You have some inputs, which are your qubit states. You have your contract that's deployed on the blockchain that computes the output, and then you receive an output in return. So, for learning objective 2, to describe the process of deploying a smart contract, I'm going to have you guys think about which order you'd want to take these steps. And if someone decides on an answer, feel free to shout it out, raise your hand. Okay, so for the last part of this talk, I'm going to talk about things that you can do on the blockchain. So one of the biggest applications of smart contracts is creating automated market makers. So basically what they do is that they receive a bunch of bids and a bunch of sell orders, and they decide on the optimal price for coins within Ethereum. Like for example, Dogecoin. Another example are DAOs, or decentralized autonomous organizations. So within these, you can have people buy shares of a voting organization and use those shares to cast votes and make decisions. So what I leave you with is a vision for the future where we have smart contracts that can do matrix multiplications. And if you can do matrix multiplications, you can do basically anything. So walking away from this talk, I hope you'll be able to think of possible uses of the Soulmate library to do more than we can have ever imagined on the Ethereum blockchain. Thank you.